This is the Algebra 2 practice final from the green workbook, just the even solutions. Question number 2. When you're looking at this one, whenever you see variables in the exponent, you want to think common bases or like bases. So I'm going to turn 8 into 2 to the third, all raised to the third, and I'm going to turn 4 into 2 to the second, all raised to the 2x minus 5. Now this is an example where our exponent rules where we multiply. So this equals 2 to the 9x equals 2 to the 4x minus 10. You have to distribute that thing. Remember, once you have common bases, you can go ahead and set the exponents equal to each other and solve from there. So we're looking at 5x equals negative 10 divided by 5, and x equals negative 2. Number 4. Number 4 says log base 4 plus log base 3. And what does it equal? Well, what you could do, oh, actually I wrote that wrong. It's actually log base 4 plus log base 10 for log 3. Okay. And this is an example of the product rule, where you can go ahead and rewrite these as a product. Okay. Just simplify a bit. You're looking at that. Okay, so it looks like D. Number 6. Number 6 says they tell you that log base 5 equals k. And they want you to find log base 25 in terms of k. So log base 25, I can use the product rule and rewrite that as this. And with all of our logarithms, guys, you have to throw log rules at it. Keep trying to use your log rules. If you're trying to use something else as a logarithmic rule, it's not going to work. And these both equal k. K plus k is 2k. Number 8. Number 8 says, which graph represents this? Now, I taught you a way to memorize this. You could memorize it, or, which is going to be a problem, because you'll forget basically how to test this. So look at the graphs. And what you want to do is always start by testing the point 0. Alright? So what happens if you put in 0 for the x? What you get is all to the 0. Anything to the 0 power is 1. So one of the coordinate points is 0, 1. So if you look at the picture of the practice test, there's only 2 graphs that go through y equals 1. There's A and C. So that basically leaves us with this 2 options. Either it looks something like this, right, or it looks something like this. You see how these both go through y equals 1. Now the next question is, okay, how do you tell them apart? Well, what I like to do is I like to pick a number like 2. X equals 2. And if the number comes out large, it's going to be this picture, which would be C. If it comes out small, or a fraction, small fractions, then it'd be this one, which is A. So if I go ahead and do that, and I go, well, this equals to the 1/8 squared, that equals 1 over 64. That's a pretty small number, so it's going to be this picture right here. Okay, if I would have picked the -2, I would have had an inverse relationship. Number 10. Okay. Number 10 says log base 16 1 over 64. Now, you can reason your way through this. Either way, you got to do this process, which I'm about to do, in some way. But I like to set it equal to a dummy variable, just to kind of help me. So I use A. Don't use X, because then there's already X in a problem. And what I do is I walk the dog over here, and I'm looking at 1 over 64 equals 16 to the A. All right. So once again, I see a variable in the power, so I need to think like bases. This first step that I'm about to do from here is where people tend to make their mistake. And the first thing is, well, you got 64 and you got 16, so I can get those to bases of 4, but this one with the fraction causes an issue. So this is what I'm going to do first. Okay, and say 64 to the negative 1. All right, now I'm going to convert this to powers of 4. And now I can remember this is where I multiply the powers. The 2a, I have like bases. I can go ahead and set the powers equal to each other. Divide by 2. There's my answer. Negative 3 halves. Okay. And that was number 10. Number 12. Number says, which is the first step with an error? Okay, so basically, let's just do this question right and see what happens. We're looking at, here's the original question. Okay. This is an example of the product rule. Right? So I'm basically looking at 2x equals 2, and then from here you can walk the dog over or think of putting these on bases of 6, but either way the next thing you would have is something that looks like that. Alright, and then you would have 2x equals 36, and you can see here they made that mistake in step number 2. Number 14, okay. Using the graph shown, which value of x would make the graph closest to the x-axis? Well, you should be able just to look at the picture and figure this out. So number 14, here's the diagram here. And then the graph looks like this, roughly. It's actually a little steeper over here, but so they give you some values. They give you 0, they give you positive 1, they give us negative 1, and they give us negative 2. These are all x values, right? And they're asking us which one of these will get us closer to the y-axis, meaning which has a smaller y. And you can see one's over here, this one's right there, and you can see that they get smaller as we get closer to the negative, so the answer is the negative 2 will do it. Number 16. Number 16 says simplify, and then it gives us something like this. Log base 12 16 all over log base 12 2. This is not the quotient rule. Okay. On a side note over here, okay, on a side note, this is an example of the quotient rule. Okay, one single log that has a fraction in it. These are completely different things. This is change of base formula. So what this actually is going to equal by using change of base, I would say log base 216, right? And you can reason your way through this if you want, or put a dummy variable in there, but what do you have to put on 2 to get 16? The answer is going to be 4, but if you need some help with that, you can go ahead and walk the dog over here, convert these both to bases of 2, and you could say, yeah, a equals 4. All right. That was number 16. Okay. Number 18. Okay. 18 says the graph shown would be the graph of which equation? So they give us this ellipse. Okay, they give us this ellipse, and it has a center at 0, 0. This coordinate right here looks like 1, 2, 3, 4. So looks like positive 4, looks like negative 4, and then negative 2 and positive 2. Then there's our ellipse, right? It's kind of in this general region right here, and they're saying which one of these equations has it. Well, in this case, we know that since this is the square root here, that if this was an ellipse, it's got to be a plus. Okay. If we do x and y here. Well, the x one goes 4, but remember that's the square root of it, so that's 16. The y one goes this way here, and they're always equal to 1. Okay, you got to kind of just graph that backwards in your head. Number 9, we don't do 19. We do number 20. And number 20 says, what is the radius? So they give us this, and whenever we're doing conic sections of any kind, we have to ask ourselves, okay, are these things in the standard form? Meaning, has the square been completed? In this case, it's not. This is a perfect square right here for the y, but this x tells me this is not. So I have to complete the square right here. And if you remember how to complete the square, that's b over 2a. That tells me what number I'm about to add right there. I'm going to leave my y squared there, and I got my 9 over there, and I have to add it to both sides. So I'm looking at b would be my 8 would be my b, so that's divided by 2 is 4. Square that, that's 16. That has to go to both sides. And then I would actually complete the square here. Oh, sorry, there's no that. To the 4th squared plus y. If this helps you understand what's going on, it's at the for the center it equals 25. So the center here, the center of this thing is 4, 0. I don't even know if they're asking for that. Number 20, they want the radius, so that was the center. The radius is not 25, it's the square root of 25. So the radius is 5. All right. 22. Find the focus. So we're looking at x squared all over 9 plus y squared all over 5 equals 1. Right. And this is a ellipse. I see the plus, I see it's equal to 1, so I need to use this formula right here. Okay, or whichever one of these is bigger, so it may switch A or B. You need to ask yourself, which way is this thing going? Is this going to open, is it a vertical, is it wider vertically or horizontally? And since the x value here underneath is bigger, that means the ellipse is going this way. So that means when I use this formula, I'm going to add everything to the x coordinate of the center. And the center, these are both zeros, so the center to help me here is 0, 0. And whenever I find the focus, whatever value that is, I'm going to do plus and minus to the x coordinate, because the focus is a coordinate point, right, or the foci. So we're going to say c squared equals 9 minus 5, c squared equals 4, c equals plus or minus 2. So the focus are actually going to be the coordinate point 2, 0 and negative 2, 0. You'll also see that is probably written like this. You have to go back and add it to the center.